Most products. So what I would like to highlight regarding the very recent achievement is the level of maturity that we have achieved regarding the implementation of operational systems to forecast and monitor atmospheric composition and air pollution events. We have also achieved a first step in the implementation of our CO2 MVS system. CO2 MVS is a CO2 greenhouse gases monitoring, verification and support system, and we have launched at the beginning of the year the new methane emission hotspot explorer that allows to track, to monitor methane emissions from coal mines, oil and gas activity or landfills. And this is a very interesting product. I'm very proud that it could be used to support the implementation of environmental policies regarding methane. I would say uptake of the data that will be provided by new space satellite missions is certainly the top priority for CAMS. Of course, you are aware that the Sentinel-4 mission has been launched in July successfully. This is the first geostationary satellite for Europe, focused on Europe, that will be able to provide information on air quality over Europe and for North Africa as well. So we will have new information on air pollutant concentration level everywhere with a very high temporal frequency of 1 hour. There is also the Sentinel-5 mission, which will provide also some information about air pollutant and methane, but also other missions like microcard for CO2 and other instruments that will be very valuable. So this is very exciting time. A lot will be available to improve our system, to improve the forecasting capacities of our system at the global scale and at the European scale, but also to improve our capacities to monitor and to verify emissions. We have already started to think about that. There are several options to use AI technologies to improve our systems. First, AI/ML will be very useful to emulate our very complicated, our very complex chemistry transport model and atmospheric composition models that we develop. And with AI/ML, we hope that we will be able to improve the forecasting and the reanalysis capacities of those models. There is another possibility. This is to work on how to downscale physics-based model to provide a better, higher resolution information over some areas, and also to design new products that could be tailored for policy needs, for instance. So this is another option. And the third option is really to explore the capacity of observation-based, observation-driven models to develop new forecast products, to improve our products, but also to take stock of the wealth of data, observation data, that is available for atmospheric composition in space with satellite missions, but also on the ground with in situ networks that are implemented everywhere. You know, CAMS is built upon, and this is really what made the success of CAMS, the integration of a wealth of data coming from Earth observation, in situ network, modeling framework. And I think that also in a long-term perspective, with new technologies, certainly with AI/ML, with new monitoring networks, with new Earth observation capacity, we have to continue to work on the integration of those systems at the global scale, but also at the European scale, bridging the scale to provide better information about the evolution of atmospheric composition, understand the trends, understand the impact of the mitigation strategies that could be decided to deal with greenhouse gases or to deal with air pollutants. This is our top priority. So this is an aspect of our strategy, working on the integration of this data with new technologies. And for what? To design policy products, because this is also one of the priorities that have been given to the Copernicus program and especially to CAMS. This is to support the implementation of EU policies and also role of EU policies in international agreement. And with that, being able to bridge those scales from Europe to the global scale, because you know that atmospheric composition has no limit. With that, we will be able to play our role, our scientific role, scientific advisor, to help in the implementation of policies, of course for policymakers, but also for the citizens.